Hello, this is Spirit Plumber from Robots Everywhere. The purpose of this demo is to show you how to modify a servo for continuous rotation without using any kind of electrical tool. See here a standard issue servo. This is a servo driver that we use for testing. You can see that the servo moves according to the rotation of the potentiometer. This is the standard behavior for a servo. What we want is we want to make it rotate and have the knob decide speed rather than position. There are tutorials to do this with, but they generally involve opening up the servo, changing its circuitry, and making an irreversible modification. This is reversible and this does not require a soldering iron. First thing, you remove the actuator. Now this is a sample actuator that I hooked up so that you can see what I'm doing on camera. And then you open up the servo. It generally requires a Phillips screwdriver, sometimes a Torx depending on the servo type. And there's two things you have to do. You have to make sure that the potentiometer is centered, and you have to remove the mechanical stop. Now in this case, the bottom of the servo came off. You can see here the circuitry. The good news is that we won't be touching this. For the record, if you care, the motor is here. There's usually some kind of microcontroller here. In this case, it's in the back of the board. And the potentiometer is here. You can see the 3 pins. What we care about is the mechanical part, which is up top. This needs to be opened up carefully. Otherwise it's a giant mess to close it later. First thing you do is you make sure that this is the potentiometer. It can rotate. There's a little rectangular knob on it. You make sure it's centered. In some cases you may actually want to mechanically block it somehow. The second thing you do, this is a smaller flat screwdriver. You can see the corresponding slot to that. This is the actual wheel that moves the actuator. You want to remove this slot. Fortunately, most servos you can just take it off as it's a separate piece of plastic. In this case we have to remove this little ring, remove the slot. Now you want to keep this if you ever need to reverse this modification. Put the ring back in. Now the ring is important because one thing that's going to happen is that a continuous rotation servo is going to move a lot more than a standard servo, obviously. So if you want to put extra lubricant in this, now would be a good time to do so. Vaseline will work. In a pinch, olive oil will work, but that's going to start to smell eventually, so I recommend against it. The next thing you have to do, there is a mechanical stop on this gear to prevent a full rotation. You can remove it. You generally have to rub it out with a nail file or the like. Now what that's going to do is, if you undo the modification, you'll still get a stop because you will eventually hit the mechanical limit of the potentiometer. That means that you shouldn't put too much torque on it, but on most servos that's not an issue anymore. Carefully remove the gears and make sure you can put it back together because they do interlock somewhat. It can be a bit of a pain in the neck to put them in and take them out. So carefully remove the gears. You generally end up having to remove all of them. This is the one you want to mess with. This is the part that pokes out of the servo, as you can see. There will be a stop. In this case, it barely shows it here. To touch against these two protrusions in the servo. What you want to do is rub it out so that it does not bother you, or it does not bother the rotation. This can be done with a nail file, with nail clippers even, or with fine grain sandpaper. If your gear is metal, you will probably have to use the sandpaper. Now, one thing you want to do is you want to be very true when you do this, because otherwise there will be a little indentation left. The servo will work, but it will stop once it turns, or slow down once it turns, as it tries to clear the hurdle. That's not good for the motor, and it's probably not good for your project, because it introduces an effect that you are likely to not want. Now this takes some time. Not much you can do about it. If you have a soldering iron and you do want to take a soldering iron to this thing after all, you can also kind of rub it out with it. I recommend against it because it's very easy to dig too far into the plastic, and that's hard to undo. Now this is the place where even most cheap servos have a ball bearing in and out. One thing that can happen is that this plastic dust can gum up the ball bearing. Again, what you want to do is make sure you use a little bit of extra lubricant. Again, Vaseline is fine, motor oil is fine. Try to not mix the two if you can help it. What is important is that you completely rub the protrusion out. This is the only permanent modification we're doing here. Smaller servos may not even have this. It may be built into the potentiometer, which we have now mechanically disconnected, so we don't really care about that too much anymore. Once it's done, you have to rebuild, so you have to basically rebuild the gears. That tends to take a bit because you have to kind of do it in one go, but it is reasonably doable. If you get it wrong the first time, don't panic. Remember that it got out, so it has to go back in. Note that for this particular servo, one gear stayed here because it actually goes under this metal ring, so we're going to leave it there. Make very sure this is centered before you close it. Again, one thing you may want to do, if this thing is going to get banged around or it's going to be subjected to a lot of vibration, you may want to block it with something. Now you can close the servo. What we should expect to see now is that the knob, instead of controlling position, it will control velocity. So the servo will not move when it's in the middle, when the knob is in the middle. It will move slowly when we move it slowly one side or the other, and it will move at full speed when we slam it one way or the other. This can be used for a number of projects. Again, there are many demos about continuous rotation servos on the net. I am just trying to show you a way to do it quickly and, most importantly, reversibly. You can see here the modified servo. It will rotate depending on the knob's position. You do have some control over the speed. That's generally not the case with analog servos. It is the case with digital servos, which is most servos made in the last 10 years.